Okay, Unit 12, Day 1. Little Enter Sandman for those Hokie fans. They go crazy over this song, don't they? Okay, so let's get started. So we're going to do Unit 12, Day 1, normal distributions, as you can see. Anybody know what this is called here? That's right, it's a bell-shaped curve. That's what a normal distribution is. It forms a bell-shaped curve, okay? So here are some characteristics, as you can see. So it's symmetric, so if we draw a line right down in the middle, it is 50% on the right, 50% on the left. Okay, so that's why a lot of people refer to this as a bell-shaped curve. Okay, the mean, which is the average value, is always in the middle. Okay, so it more or less cuts the distribution in half. Okay, the mean is always in the middle. Normal distributions will look different. We have what's called a standard deviation. Okay, standard deviation. That is basically how far it is from the middle, the mean. So it's always important to remember that the mean is always in the middle. Okay, so here's some examples why they could look different. Just imagine if we had, 30 people in class and our quiz grades were very, very close together. Okay, so maybe from 85 to 95. So that would look something like this. Okay, try to imagine, stuffing those 30 students into a tent, and if their scores are really close together, the tent has to be really tall in the middle. Now, let's say we have a quiz and the grades go from a 5% to 100. So they're really spread out. So that's going to look like that, okay? So here's the mean in the middle, all right? So that's how they can look different. Now, for our purposes, we're just going to draw a normal bell-shaped curve to draw the numbers, as you can see. All right, so normal distribution. So you see this N, that stands for normal distribution. This symbol here is mu, okay, which means the mean. This symbol here is little sigma. That's your standard deviation. So if you have a normal distribution, you are always given the mean and standard deviation. Okay? All right. So let's look at this one. So this right here is our mean. That's our average. This is our standard deviation. Okay? So we're going to draw a normal distribution. So let's do it this way. So let's always start in the middle. Okay, so that's your mean, that's your average. Now, we always need 3 standard deviations to the right and 3 standard deviations to the left. Now, these are equal values to the left and to the right, but if our standard deviation is 2.5, that means we will add 2.5 as we go to the right, and we would subtract 2.5 as we go to the left. Okay, now these numbers are pretty close. 2.5 is a small number. So this is going to be a little taller in the middle. So it looks something like that. Yeah, hopefully yours is going to be a little nicer than that. Okay, now let's look at this one. So the mean is still 50. But now the standard deviation is 15, so the numbers are a little more spread out. So we're going to put the mean in the middle. Now these are going to be a little more spread out, so we need 3 standard deviations to the right, 3 to the left. Okay, so these are a little more spread out compared to the last one. So as you go to the right, add 15. As you go to the left, you subtract 15. Okay, so these are a little more spread out, so it's a little flatter bell-shaped curve. All right, so let me go back to the other one real quick. 2.5, that kind of pushes I don't know how well you can see my fingers there. That pushes the numbers together, so it's taller in the middle. These are a little more spread out. Okay. All right, so here's our normal distribution. That's our bell-shaped curve. We have what is called the empirical rule. Okay, the empirical rule is 68, 95, 99.7. So the 68 comes from here. Okay, so all of this area in the middle, that is 68% of your data. Okay. Now, as we go out, so from here all the way to here, that's 95% of your data. Okay, so that's all of this area. Okay, so that's plus or minus 2 standard deviations. The 68% was plus or minus 1 standard deviation. Now, if we go out to 3 standard deviations, that is 99.7% of your data. All right, so keep in mind, if you think of your 100%, we still have a little sliver over here and over here. So that 99.7% goes from negative 3 standard deviations all the way to positive 3 standard deviations. Now let's put some of this into context here. So if 68% goes from here to here, wouldn't it make sense that 34% is there and 34% is there because of the symmetry? Okay? Now, if we go from here to here, plus or minus 2 standard deviation, that's 95% of your data. Well, if we take away the 68%, that leaves 27. So that means we're going to have 13.5 there and 13.5 there. That's how much percent of the data would go in that sliver there and that sliver there. So if you add up all of those numbers, you get your 95%. All right, so let's keep moving. Let's go to plus or minus 3 standard deviations. So that's 99.7%. So if we subtract the 95% that we already looked at, that leaves 4.7%. Half of that is 2.35. So that's what would go in those little slivers there. So 2.35% would go there and there. Now, if you add up those numbers, you get your 99.7%. Well, that leaves 0.3%. So that means we have 0.15 out here and 0.15 out there. Okay? Now, we're going to talk about percentiles. You guys might be getting ready to take the SAT, stuff like that. You always are given a percentile. So as you go from left to right, what are we? So if we're right here, and I'll write these numbers here at the bottom, going from left to right, you would be in the 0.15 percentile. Okay? If we're here, we would have to add up everything to the left. So that would give us 2.5. Okay? If we're here, add up everything to the left, we're at 16. If you're right smack in the middle, 50%. If we're here, we add that 34, as you can see, we're now at 84 percentile. If we're here, we're at 97.5 percentile. And again, to get these numbers, you're adding all the numbers to the left. Okay? And you can kind of start in the middle. So here you're at 50. So if I subtract 34, we're at 16. If we add 34, we're at 84, and so on. All right, so to get from here to here, add a 2.35. That means we're at 99.85 percentile. Okay? So that leaves that 0.15 out here. So there's your percentiles that I will refer to. All right. So here's our next set of questions. So let's say we take the math SAT. We're told that the scores are normally distributed with a mean of 500 and a standard deviation of 100. So the first question, what's the mu? That's your mean, 500. Little sigma is your standard deviation, 100. Okay? Now, question 2 says draw a normal distribution. Okay? So let me slide this in here. All right. So this is for our SAT. So our mean was 500. We put that right smack in the middle. Standard deviation was 100. So if we add 100, we get those numbers. If we go back to the middle and subtract 100, that's how you complete your standard deviation. Okay, so we're going to use this to kind of answer the rest of the questions. So I don't know how well I can fit all this on there. There we go. Okay, so we did our mean, our mu, little sigma. We drew our and labeled our normal distribution. Okay, so now the empirical rule. So what score would we have gotten on that SAT if we're in the 16th percentile? Okay, remember 50% is right smack in the middle. If we subtract that 34%, we're right there at 400. Okay, so this is the 16th percentile. So that means from here to the left, you basically did better than 16% of the population if you got that score. Okay, so if these are math SAT scores. If we're at the 50 percentile, that's right smack in the middle. So that means you got a score of 500. So that means you did better than half and worse than half if you kind of think of it that way. The 84 percentile, right here, 600. So that's a decent score. If you got a 600 on your math SAT, you did better than 84% of the population. Okay? All right. Okay, so here's some more questions. Now with the SAT data, let's answer some fancier questions. All right, so let's bring back our normal distribution for this data. What percent of the SAT scores are more than 700? So let's think about that. Here's our score of 700. So we have to be here and to the right. These are the ones that are more than 700. Well, that would be 2.5% of the data. So remember, we have that 2.35 here, and we have that 0.15 here. So add that up, you get 2.5%. Okay? All right, question 2. An SAT score 600 corresponds to what percentile? So here's your 600. Do you remember what percentile? So how many did we do better than? It was 84 percentile. Okay? So if you got a score of 600, you did better than 84% of the population. Question 3. SAT score 300 corresponds to what percentile? So if we're here, that means we did better than this population. Okay, not very good, honestly. 2.5%. So remember, that's your 2.35 and 0.15. So we did better than 2.5%. Okay. And then this last question, number 4. What are the intervals? Well, the middle 68% would be from 400 to 600. Okay, so that's the interval. Okay, so that's your plus or minus 1 standard deviation. So think of your empirical rule we're talking about here. All right, the middle 95%, that would be from 300 to 700. Okay, so that's your middle 95%, plus or minus 2 standard deviation. And then your middle 99.7%, plus or minus 3 standard deviation. So that would go from 200 to 800. Okay? All right. Any of you take an IQ test? All right, so let's see what we can do with this data. So brand new set of data here. Okay, so we have an IQ test. They're normally distributed. The mean is 100. So that's question 1. The mean is 100. Standard deviation is 15. So we answered question 1. Okay, the mean is 100. That would go right in the middle. Standard deviation is 15. Now, question 2 says draw a normal distribution. All right, so here's our IQ data. So if our mean was 100, we would put that right smack in the middle. Our standard deviation is 15. So if we go to the right, we add 15. If we go to the left, we subtract 15. Okay, so there's your data and your normal distribution for this set of data. The mean is 100, standard deviation is 15. Okay, so we answered question 1, we answered question 2, we drew that. All right. So 16th percentile, what would be your IQ score? If you're in the 16th percentile, here's the middle, so 16% would be 85. Okay, if you're in the 50th percentile, your IQ would be 100 according to this data. If you're in the 84th percentile, you're right here at 115. So as you go from left to right, remember, okay, this is 0.15, 2.5, 16, 50, 84, 97.5, 99.85. So remember that one, the one chart we shared with you. Okay. All right, almost done. So here's some more questions. So we still have our IQ data. Okay, let's answer some more questions here, some fancier questions. As you can see there, it says, all right, so here's our data. What percentage of IQ scores are less than 70? So here's 70. So what percent would be less than 70 to this direction? So that's going to be 2.5%. Okay. Question 2, an IQ score of 130 corresponds to what percentile? So we're right here. Do you guys remember this one? Okay, so it's 50 in the middle. If we add that 34, we're at 84. We add that 13.5, so we're at 97.5. So if your IQ with this, this particular IQ test, if you had an IQ of 130, that means you're smarter than 97.5% of the population. Pretty good. Okay. Question 3, an IQ score of 100 corresponds to what percentile? This is kind of a freebie, right? We're right smack in the middle, so 50%. Okay. All right. So let's look at, squeeze that on here. Okay, your intervals. So the middle 68% for this data goes from 85 to 115. The middle 95% of your data, 70 to 130. And the middle 99.7% of your data goes from 55 to 145. So again, the middle 68 plus or minus 1 standard deviation. The middle 95% plus or minus 2 standard deviation. And the 99.7 plus or minus 3 standard deviation. Okay? All right, we have one last example to look at here. All right, so the EPA fuel economy estimates for automobile models tested recently predicted a mean of 24 miles per gallon. Standard deviation is 7 miles per gallon. So this is our gas mileage. So the mean is 24, standard deviation is 7. Okay, so remember the symbols. This is mu for mean. Standard deviation is little sigma. Kind of looks like that. Okay, something like that. Hopefully yours is a little better than that. All right, so we're going to draw a normal distribution with this data. Okay, let me kind of put it like this. All right, so 24 would go, this is our EPA, fuel economy. So 24 would go right smack in the middle. Okay, if we add 7, because that's your standard deviation, add 7, you're going to get 31, 38, 45. If we go to the left, we subtract 7. So there's your normal distribution for this set of data. Okay? So we drew that. That's question 2. All right, so question 3. In what interval would you expect the central 68% of the automobiles to be found? Well, remember, the middle or the central 68% is from plus or minus 1 standard deviation. So that would go from 17 to 31. Now remember, this is miles per gallon. So it's kind of important to remember what your data is talking about, right? All right, question 4. About what percentage of automobiles get more than 31 miles per gallon. So here's 31. So what percent would be on this direction? Now, hopefully you're thinking, well, this is the 84th percentile. Well, that's this way. So if 84% is this way, what percent would be this way? That would be 16%. Okay? So you have to understand what data are we talking with. Here we're talking about this direction. Okay? So this direction we know is 84%, but from here to here would be 16, because remember, the whole thing is 100%. All right, number 5, about what percent of the auto should get between 31 and 38. So that's this little sliver from here to here. Okay, does anybody remember what that is? It is 13.5. Okay, so remember, from here to here is 34%, and then from here to here is 13.5%. So refer back to that one. I'll actually bring it back here to close the day here. And then last question, describe the mileage of the worst 2.5% of all cars. Well, that's from here this way, okay? So that means you would have less than 10 miles per gallon. So that's like a vehicle like a Hummer. They don't get very good gas mileage. So that's where you would fall into play. Okay, so normal distribution. Let me bring this guy back real quick. So you got to remember your empirical rule, 68, 95, 99.7. Okay, so you got your middle 68. So that means each one of these is 34. You got your middle 95. So that whole area is 95% of your data. So that's why this guy is 13.5, that's 13.5, so you add all those up. Then as you branch out, 99.7% of your data, and then you still have your 0.15 outside of that, each side, so that makes your 0.3. Okay, so that is your normal distribution. Okay, so hopefully you enjoyed that lesson. We got a question of the day for you. What has 6 faces but does not wear makeup? What is it? Okay, so if you know that answer, email that to me. My wife actually got this one on the first try. I was pretty impressed. Okay, all right, so that concludes Unit 12, Day 1. Go Cougars!